This is an introduction to SQL injection. So it's sort of a web hacking 101 presentation.
Could it be a louder introduction?
I will speak very loudly.
Thank you.
My name is Jason. I work for a nonprofit that develops web applications for libraries. We have like 14,000 member libraries in 140 countries. So it's a big nonprofit. There are 2 security guys, so I spend a lot of my day job assessing web apps. Brief overview. How many people here are developers, out of curiosity? Anybody? A couple? Cool. Anybody that does pen testing for a living? Yes? A couple. Oh, good mix, good mix. How many people have heard of OWASP? Everybody, fantastic. So everybody knows over the OWASP top 10, right? Injection is the #1 web security risk. Why? Because it's really easy. It's easy to exploit, and the impact is severe, right? You can do a lot with it. But before we get started with SQL injection, let's just take a brief overview of how web applications work. Right? Let's say I'm looking at a sports store, and I want to see what balls they have. So your basic web app has, the architecture is 3 layers, right? You have the presentation tier, which is your user looking at a browser. You have a logic tier, which is PHP running in Apache or Ruby running in IIS. And then on the back end, you have a database, MySQL, SQL Server, something of that nature. So if I want to look at all the balls in a store, I click the button to check that out. And in the URL there, it's important to note that at the end, we're sending a get parameter. We're saying I want to see everything in the category balls. And what the logic tier does is it, at runtime, dynamically creates a SQL statement, right? It's a select star from products where category equals, in single quotes, balls. The database says, I've got that. Here is all the balls I know about. And the logic tier sort of massages that data and then presents it in a cool graphical presentation and sends the presentation to a website. Now let's take a look at that in the context of a login page, right? Here's a quick PHP script that just logs someone into an application. Up at the top, it connects to the database. On the next lines, it builds that dynamic SQL statement, right? Select user ID from app users, where user equals whatever in the username box, and password equals whatever in the password box. It then runs that query, and then in a function, we figure out how many rows it returns. The logic is that if it's a valid username and password combination, we'll have 1 row. But if it isn't, we'll have 0 rows. And then the logic at the bottom says, if numRows is not 0, log us in. Else, throw an error. So here's what it looks like when we have a valid username and password, right? JSmith, password kitty. It gives us some nice, logical, good-looking SQL. But let's say in the password box, we throw something in there. Let's say we put a little bit of SQL in there. And we do it in such a way where we change the logic of our where clause, right? We threw an or in there, and we say 1 equals 1. Well, 1 always equals 1, so that's always true. So that entire where clause always evaluates to true. And just based on our logic, if numRows isn't 0, we log in. And in this case, the database returns all of the rows, right? So the numRows is however many users we have in the database. So what we do is we're then able to inject some SQL that bypass the authentication mechanism in the application. SQL injection can be used, pretty much anything that you can do with SQL, you can do with SQL injection. So you can add data to a database. Let's say you're adding users that don't really exist, sort of creating a backdoor in case it's patched just to have a way in. You can alter data, you can delete data, you can drop entire tables. Most databases have functionality that allow you to run commands against the server through SQL. So if we can run commands with SQL injection, we can completely compromise the database server. Database server is typically not in the DMZ, but in the internal server. So once you own a server on the internal network, you can pivot and attack the rest of the network. Altering data is also kind of interesting because let's say instead of just injecting random data, we inject some malicious JavaScript code, right? So when other people go to that page, what loads is a bunch of malicious JavaScript. Malicious JavaScript that, say, infects a machine and then adds that machine to your botnet. So using SQL injection, you can not only attack whoever you're attacking, but you can attack the customers of that page as well. White Hat is sort of an interesting company. White Hat assesses web pages, and they do it as a software as a service model. So from White Hat's cloud, they scan your web page and tell you what's wrong with it. Every year or so, they release some statistics. The last one was in July, and out of their customer base, about 11% of the web applications they look at are vulnerable to SQL injection. I would say that, you know, if you're paying for the service, you're probably sort of the subset of the internet that's a little more secure than others. So I would say that that number is a little low, you know, from the entire internet. The web hacking incident database keeps numbers about different security breaches, different web app hacks. They've been doing this for several years now, and according to them, SQL injection is the #1 attack used on the internet. So it's your #1 attack. You have at least a tenth of the internet that's vulnerable to it. It's easy to exploit, and the impact can be kind of bad. So it's definitely a problem, right? So, all right, it's a problem. If we're going to look at a website, if we're going to assess that website, how do we find it? It's something called testing by inference, right? Generally, when you're hacking a web page, you're not looking at source code, so you're not sure what's there or not. So what you do is you play around with inputs, right? You add some stuff to it, and then based on the responses that you get, you sort of infer what's going on in the back end, right? You don't see the SQL statements that's being built, but you can guess on what's going on. And the easiest way to detect SQL injection is to throw some stuff in there that is going to make that SQL not correct, right? Break the syntax of it, make it look bad, and then hope that the application gives you an error. A very, very easy thing to do is just a single tick. You throw a single tick in there, the ticks on that SQL query don't line up, and you get an error. Other easy things to do, start a comment, end a comment. If you have an input that's a number, throw some letters in there, add some extra spaces. Here is a bunch of errors that websites throw just by that single tick. The one on the bottom left is a Cold Fusion app that actually shows you the entire SQL statement. So there you're not inferring anymore, then you can actually see the code. Other things that happen, instead of, you know, if the web developer is actually handling errors correctly, right, they're not going to show you that database error. They might show a custom application error, right? You might get a little red line that says, hey, something went wrong. They might display a web page, but then give you an HTTP status code. Or maybe a timing issue, right? Maybe if it's a bad SQL query, it takes a second longer to run than a good SQL query. Or differences in a web page. You know, instead of showing you all of the balls, it's a blank web page, right? There's a definite difference there. There are lots and lots of applications out there that are sort of purposely vulnerable. The budget store is another OWASP project. So you can download it, install it, and sort of hack away at it, right? So it's good practice, it's good learning. Here, if you can see in the username, I put test and then that single tick. And what it did was, came back with a custom application error. It just says system error. Now the issue with custom errors is that it's difficult to tell whether or not it was a SQL injection issue that caused the error. So what you need to do to validate that is sort of massage that input a little bit, right? So instead of just the single tick, I put a tick or 1 = 0. And on the back end, that creates a valid SQL statement. So the custom error goes away. We didn't log in, but the custom error went away, and you can sort of infer that there's definitely a SQL injection issue going on. So other things you want to look at, right? User agent strings, cookie values, any input that's going from the browser to the web application that might be used in a SQL statement on the back end. You want to sort of try all of those inputs, right? Hidden form fields and everything, no matter if you can see it or not, play around with it, see what you get. Now there are some automated ways to do this. One of the easiest ways to start is just with browser plugins, right? If you go to the Firefox plugin page and search for SQL injection, you get a bunch of fun tools back. SQL inject me is a fun one. It pops up a little bar on the left side of the web browser. You can select what inputs you want to play with, and then you just hit run tests. It'll run a bunch of tests, open up another tab, and say, here's the results. Tamper data is really cool because what it does is it acts sort of like a quasi-proxy, right? Once you hit submit, it pops up and says, hey, this is everything that we're submitting. This is everything that the browser is giving to the web app. And here I use the budget store as an example, and so you can see the username and password as inputs. If you right-click on those, you get a drop-down box of a bunch of pre-canned attacks that it'll run, and one of them is some SQL injection attacks. If you want to take a step beyond that, you have web application vulnerability scanners. Now you can pay thousands of dollars for HP's Web Inspect or hundreds of dollars for Burp Suite. Thank you. But there are a couple that you can download for free, right? They're open source. W3AF is a Rapid7 sponsored project. It's one of my favorites. You have a bunch of plugins that are attack modules. You give it a URL, you give it what attacks you want to run, you hit go, and then it comes back with what it finds. Here is W3AF finding a SQL injection vulnerability within the password parameter of the budget store. Another favorite is an OWASP project called the Z attack proxy, or OWASP ZAP. Again, it's pretty simple to use, it's free. You set it up as a proxy, it sits in between your browser and the web app, and it can watch traffic, and you tell it to spider, right? So it goes out, it goes across the entire web page, sees what's there, and then you can right-click and say attack, and it will run some pre-canned attacks against the page and then show you what's wrong with it. Here is ZAP finding the vulnerability within the password parameter of the web page. If you want to go a step beyond finding things to actually exploiting them, one of my favorite tools is SQL Map. SQL Map is amazing. It will actually compromise the backend database if you wanted to. I've used to dump entire databases of applications that I'm assessing. It'll give you usernames and password hashes, like actual database logins. It will also just do some enumeration and tell you what database is running in the backend, which can be very valuable. It's command line, but it has a wizard mode, so if you just run it with -- wizard, that's really dark, you can't see that at all, can you? But you can give it a URL, it sort of walks you through setting up an attack. So it asks for a URL, and then I tell it what parameters to test. And then you have some options around how aggressive it is. You hit go, and then what it found was the SQL injection vulnerability in the username parameter of the budget store. You do have to be a little bit careful with automated tools. I just showed you 3 tools, right? SQL Map found the injection vulnerability in the username parameter. The other 2 found it in the password parameter. So they're both vulnerable, but it's sort of hit and miss on what exactly it finds. Now, if from the developer's perspective, if you actually want to stop SQL injection from happening, right? If you're giving them a report or you're a developer yourself, the advice for how to prevent it within code has sort of changed over the last few years. 5 years ago, I would tell you to filter your inputs, right? If it's a number you're accepting, don't accept letters in that input. Don't accept things that look like SQL, right? There are whitelist approaches and blacklist approaches. Approaches where you don't allow any bad characters in, or approaches where you only accept a known set of good characters. The recent advice, though, is to do parameterized queries. What this does is, within the code, it separates user input from your SQL code, right? So it doesn't allow any user input to be ran as SQL at all. Like anything in code, right? You want to test it. Here and there, I've seen where it does have sort of a performance hit. So if you're testing and it has a negative impact, right, you can use the other stuff, or you can use blacklist and whitelist. You can use the input filtering instead. That's more or less everything that I had. That's just a quick introduction to SQL injection. At the end, I have a bunch of sources. So if you want to go and try some SQL injection, right? If you want to go and hack at some web applications, right in the middle there, the vulnerable web apps. OWASP has a project called Broken Web Apps, which is a VMware of at least a dozen different web applications, right? The budget store is in there. It has a couple of real vulnerable, like WordPress is in there, right? It's an old version of WordPress that has some issues that you can test against. And then Backtrack, right? So you have a virtual machine of an attack platform. Every tool that I use, every tool that I showed, is built into Backtrack. So 2 virtual machines you can run against each other and run some stuff. That's all I have. I'm going to throw the slide deck up on my webpage. If you want to contact me via Twitter or email, go for it. Any questions? No questions? One?
You mentioned advice and parameterized queries. Can you speak about the OWASP ES API a little bit?
Yeah, so OWASP has a project. It's the Enterprise Security API. I call it SEPI. Other people pronounce it differently. But it's, I think it runs in Java, and I think it runs in a few other languages, right? They're sort of projects that go together. It's a set of plugins, right? It's a set of functionality that instead of security can be difficult trying to do it yourself, right? Instead of trying to filter things out yourself, doing the input validation, if you can just call a function and have that function do it for you, that makes things a lot easier on a developer. And most languages have some sort of a library to do security easy. SEPI is one that OWASP provides. So you download it, right? You include it. It compiles on the code, and you have a bunch of functions you can use to do things securely. So yeah, I'd recommend that as an OWASP project to check out. One in the back.
Why don't people just use internal database functions or stored procedures? Is there any disadvantage to that?
Stored procedures is another name for parameterized queries. But yeah, stored procedures, if that's what you want to call it, yeah, that's one way to go, yeah.
How is there much of a performance impact? I mean, you were saying that there's a possible performance impact. Aren't a lot of database functions inside the database compiled and optimized?
It's just something I have to test. I mean, from the research that I've done, I've seen some instances where it runs a lot better, and some instances where people complain about a performance impact. So it's just something you need to test in your own application, see what works, what doesn't, and then go from there. All right, cool. Thank you guys for coming. Enjoy the rest of DerbyCon. Although there's not much left.